Hello, everybody. Happy Friday. You're probably watching this on Friday. We're starting a new chapter. Um, oh, and a word about your tests. Well, actually, I'm not sure. It depends what time you're watching this video. As of early this morning, I have not had a chance to take a look at the tests yesterday, except some of them that were coming in. I was looking just to make sure that it was working, but I haven't had a chance to grade those and get those out. From what I hear, there were a couple problems. Um, Specifically, the one that you would have noticed would be some of your coterminal questions. It asks for a positive and a negative, and a lot of the options didn't have both a positive and a negative that worked. But at least every one that we've looked at so far, it has had two answers that were both correctly coterminal. They just weren't both positive and negative. So I have to take a look at that one. And then I'm also hearing that one of the other problems was not accepting some answers that should be correct. So I'll have to take a look at that later today. But in the meantime, we're going to keep moving forward. Starting a new chapter today, we're going to take a look at the graphs of sine and cosine functions. And so I'm going to introduce this by first talking about a new term that is periodic. If I say that a graph is periodic, that means that it is a graph that repeats. Now, it doesn't just repeat once or twice, it repeats forever. And so we'll see a lot more normal periodic graphs, but I'm going to start with this one that's kind of an odd looking graph. When I say a graph is periodic, what that means is that it has translational symmetry. In other words, if I take this graph and I slide it over by some distance, it ends up looking exactly the same. And so I just slid it over by this amount right here from that point to that point. That distance that I was able to slide it over and it looked exactly the same, this is called the period of the graph. And so that distance is the period of the graph. And I should be able to take that. I'm going to have to lock this together. Let's see. There we go. So that would be the same as that distance, or that distance, or that distance, or any set of points that is corresponding, the place where it crosses the x-axis. If it is truly a periodic graph, then that is the distance that you could slide it over and have it repeat itself. And so the sine and cosine graphs that we'll see in just a moment are both periodic, and they have a period of blank. And now part of what we're going to be dealing with is that we are going to define these things in two different ways in terms of both radians and degrees. When we're looking at the unit circle, thinking about sine and cosine values, we've seen that if I start at 0, the sine value goes up to 1, and then down to 0, and then down to -1, and then up to 0, and then it repeats. And there's the important part. The fact that it repeats once I've gone around 360 degrees says that that will be the period of a sine or a cosine graph. We'll see both of them, but they both have the same period, a period of 360 degrees, because that's when it starts to repeat over again. And then when we do the same thing in radians, the period of both the sine and the cosine graph is 2 pi. Because again, that's one full rotation. And so a big part of your homework assignment, the front, or I guess the first page of your homework assignment, is you going through and taking the time to figure out what these graphs look like. And I am going to suggest that as you're working on these problems, you see that I've got a horizontal scale. I haven't labeled it yet because it depends if I want to do this in radians or degrees. I want to choose an interval that's going to be convenient for me. And as strange as it sounds, when I'm doing this in radians, I'm actually going to say that each one of these intervals is 15 degrees. And 15 degrees seems like a weird number for me to choose, but if I choose 15 degrees, then this one's 30, this one's 45, this one's 60, and that 30, 45, and 60, those are three different places where we know what the value of sine is. As for the vertical scale, I'm going to lock this in. That's supposed to be a 1 at -1 to +1. Because the sine value, again, back to the unit circle, we know that the sine value can never go below -1, nor above +1. So everywhere on the unit circle, I'm locked in between these values. And so some significant points that we can find, we know that sine of 0 is 0. And by the time I get up to 90 degrees, the sine value is 1. So 15, 30, 45, 60, let's see, that'd be 75. 90 would be right there. So at 90 degrees, we'll be up to a value of 1. But this is not going to be a straight line. And that's part of what you're going to be doing as you're doing your homework and graphing these things. We know that it gets up to, let's see, when I go to 30 degrees, we know that that is a sine value of 1/2. So at 30 degrees, we're already halfway there. At 45 degrees, it's the square root of 2 over 2. Well, the square root of 2 over 2 is, I'm plugging in my calculator, it's about 0.707, so not quite halfway there. And then sine of 60 degrees, we're looking at the tall, skinny 30, 60, 90 triangle. It's the square root of 3 over 2, which is about 0.86. And so we see this graph, it kind of goes up fairly quickly and then slows down and levels out as we get to the top. And I'm doing your homework for you by doing this, but that's what you're going to do in the assignment. Figure out what this graph looks like. And I'm not going to do a really great job of this right now. I'm going to count 1, 2, 3, 4, 5. So right here would be 180 degrees. It's going to be back down to 0. Oops. And then by the time we get to 270 degrees, it'll be down at -1. And you're going to end up getting a graph. And I'm doing a very sloppy job of this. I'm sure you'll do a much better job on your homework. But you get a graph that looks like this. We're going to refer to this as the sine curve. Because, well, that's what it looks like. And this is one period of the sine curve. After this point, I've gone all the way around. I'm back to 360 degrees, and so then it repeats itself. You'll do the same thing with cosine. The cosine graph starts up at the top. Cosine of 0 is 1, but we'll see the same shape. And again, I'm being very sloppy with this just so this video doesn't end up stretching out and being 45 minutes long. But you'll get a graph that looks like that. That's what one period of the cosine graph is going to look like. And again, when you're counting off on your horizontal axis, I'd recommend counting by 15 degrees. 15, then 30, then 45, then 60, then 75, then 90. Looks like I missed it. It should have crossed the axis right there at 90 degrees. And then the same thing, the second set of graphs you're going to do is still sine and cosine, but now we'll do this in radians. And when you're counting in radians, as strange as it sounds, I'm going to recommend that you count off in pi over 12s. And that, again, seems like a strange number until you start thinking about it. Pi over 12, the next one's 2 pi over 12, but of course 2 pi over 12 reduces to pi over 6, which is our 30-degree angle. And then the next one is 3 pi over 12, which again is a familiar angle. That's pi over 4. And then 4 pi over 12, but 4 pi over 12 is just pi over 3. And all three of those are the equivalent, the radian equivalent of 30 degrees, 45, and 60 degrees. This one ends up being pi over 2. It'd be 6 pi over 12, which is pi over 2, which is 90 degrees. And if you count off by pi over 12s, you'll get these nice numbers. So that's how you should approach those graphs. Again, sine and cosine. And actually, if you do a good job of this, your graphs in radians and degrees should look the same. We're just changing what the scale is on our graph. All right, so at that point, we know what these curves look like around x equals 0. We're starting at x equals 0, but because they are periodic, we know what they look like everywhere. So if I wanted to think about what these graphs looked like between 3,600 degrees and 3,960 degrees, well, it's going to look exactly the same as it would look between 0 degrees and 360 degrees. Because 3,600 is 10 times 360. So we can think of this as going down a sine curve and repeating, going through 1, 2, 3, 4, 10 repetitions later, we'll be at 3,600. And so since we know what the cosine curve looks like, I'm going to put 1 up here. And it'd be nice if I could see a little bit more of this. If I put 1 up at the top, then -1 would be down here. Well, we know what it looks like between 0 and 360, and that's going to look exactly the same as what it will look like between 3,600 and 3,960. So I'm going to graph one period of the cosine curve. I know that it starts at 1. I know that it crosses 90 degrees later, it goes down to the bottom, and then it crosses again on the way up, looking something like that. So what is cosine of 3,600? It must be 1. What is cosine of, let's see, this would be 3,690. Cosine of 3,690 would be 0. Cosine of 3,780, that's what this would be. That would be -1, and so on and so on. We know what these values are between 0 and 360. That means we know what they are between 3,600 and 3,960. So when I do questions like this, and I want to figure out what is sine of 810 degrees? And by the way, I don't know if I need to say this, but these are obviously no calculator questions. You shouldn't be using a calculator for these problems. If I say, what is sine of 810 degrees? Well, I'm going to find a section of the sine curve that includes 810 degrees that goes from one multiple of 360 degrees to another one. So 360 degrees, 2 periods down the line, we're going to be back to 720 degrees. And so I'll think about what the sine curve looks like between 0 and 360, and that's the same as what it's going to look like between 720 and 1080. Again, multiples of 360 degrees that includes 810. And so if this is what it looks like between 720 and 1080, let's see, 720, 810 is going to be 90 degrees later. 810 degrees is here, and we're looking at a value of 1. And there we go. Cosine of 1,350 degrees, same idea. I'll find a stretch of the curve, and I'm just looking at multiples of 360. 360 once, twice, 3 times. We're at 1,080. And so 1,080, let's see, 90, 180, 270 later, that's where we're going to be at 1,350. 1,350 is right here. And so I'm thinking about what the cosine graph looks like. And you're not there yet because you haven't done the assignment, but once you've done the assignment, you'll have a better feel for what these things look like. You know that the cosine graph looks something like this. So cosine of 1,080 would be 1. I want cosine of 1,350. That's right here. And so it looks like that's where it crosses the axis, and that is 0. So that's the idea. Maybe I'll just do one more of these. Sine of 3,690. We've seen this stretch before. This is 360 10 times. And so if sine looks like this between 0 and 360, that's the same as what it looks like between 3,600 and 3,960. And sine of 3,000, ooh, I want 3,690. That would be right here, 90 degrees later, and looks like we're back up at +1. And then for some of the problems, it'll be the same idea, except instead of doing degrees, we'll do radians. So I'll just pick out a couple of these. Let's take a look at cosine of 29 pi. Now, instead of looking for multiples of 360 degrees, we're just looking for multiples of 2 pi. So this actually gets a little bit easier. It's easier for us to think of multiples of 2 pi because it's just the even multiples of pi. So 29 pi would be halfway between 28 pi and 30 pi, but it's the same idea. This is a cosine graph, so I'll think of what it looks like between 0 and 360. That's the same, oops, I should have said between 0 and 2 pi. That's the same shape the graph will be between 28 pi and 30 pi. So 29 pi is going to be halfway in between. Looks like we're down here at -1. Now some of these look a little bit more scary. Let's maybe just skip to the last one. That's probably, well, no, let's take a look at that -1. We haven't done any of those. If I want to do cosine of -5 pi over 2, well, think about what -5 over 2 looks like. Negative 5 halves, that'd be negative 2.5. We're between negative 2 and negative 3. And so when I make my graph, I'm on the negative side. Don't forget how negative numbers work, but I'm looking at, again, negative multiples of 2 pi. And so the graph between negative 4 pi and negative 2 pi looks the same as what it looks like between 0 and 2 pi. We've got a graph that looks like that. This is negative 2 pi. This is negative 2.5 pi. And that's what we're looking for here. Negative 5 pi over 2 is that location right there. And looks like that's where the graph crosses the axis. And my answer is 0. As you're working through these problems, if you're struggling, if you're having a tough time, you can use your calculator to check your answers, but please make sure that you can do these problems without a calculator eventually. For something like 77 pi over 2, well, just think, what's half of 77? Let's see, half of 76 would be 38. So half of 77 is going to be half again bigger than that, so 38.5. So you're going to be looking between 38 pi and 40 pi for that one. And then figuring out what the graph looks like between those two values. It'll be the same as what it looks like between 0 and 2 pi. There we go. I think that's a pretty good start for us. Oh, and then one more type of problem that you're going to have is kind of working backwards. So where is cosine equal to 1? Previously, you would have used the unit circle for this. Now, starting today, we're going to think about what the sine graph looks like and what the cosine graph looks like. And so we know that the cosine graph looks like this between 0 and 360. So where is that equal to 1? Well, it happens back here at 0, and then it happens again over here at 360. So my answer would be theta equals either 0 and 360, if I'm doing this in degrees, or if I want to do the same thing in radians, or we would say 0 or 2 pi. And I'll specify I want the answers in radians or degrees, but we can do both, well, pretty easily. Okay, that is where I will stop for today. As always, if you've got questions, and if there's questions that come up on the test, certainly let me know about that. Otherwise, we will see you next week. Have a great weekend. Bye-bye.